Hey everybody, this is Sean. I'm back, and we are doing the final pieces of 2023 through 46. Now, just to remind, as I don't think I said on my other video, that this is the second test of the three that are on for what I'm doing with a CWI off this SI Certs program. Now, mind you, that I am sponsored by nobody. I've paid for this, for all the information they give me, plus the tech support and everything else. So, I am not going to say how much I paid for this or anything, as I did do an extended course as well. So, just to let you know, because I'm not going to be at fault for saying what I paid for this, as prices do change. So I know Hobart's can be different than SI Certs to some of the others like AWS and stuff I've mentioned already. So like Atlas and things. So I am not going to be responsible for prices. I'm just letting you know what I have had to do to make sure that I am prepared. So as we are going here, like I said, it's going to be 23 through 46, so that is just a few questions, as this is the second half, but this second half is going to be a lot quicker than that first one. This should be about 20-22 minutes of video compared to almost 40 minutes on the last one. So anyway, let's go ahead and start this up. Question 23 is, which of the following is true regarding performance qualification record WQTR4? Now, this is documents 10 through 13, so you have 10, 11, 12, and 13. Each one is a WQTR. Now, the five possible answers are: no destructive tests were performed, which invalidates the WQTR. The qualified weld polarity is incorrect. The qualified range for fillet weld deposit thickness is incorrect. The base metal number qualified range is incorrect, and none of the above. Now, as you look at this, I don't remember what WQTR means. It's like Welder's Quality something report. I don't remember exactly. But as I go through this, I'm going to be looking at which of the following is true regarding the performance qualification. Okay, so we're going to look at the metal, and what they're doing is like actual values and ranges qualified. So as we're going to be going through this, I was saying it's gas tungsten arc welding. It's going to go through everything. And one thing that really jumps out on this one is the weld polarity. Because it's welding current type, AC, DCEP, DCN. You have actual values as DCEP. Range qualified is DCEP, which is direct current electropositive. And DCEN is exactly the same, except the N is negative. Now, you kind of go through this, you're like, okay, so no destructive tests were performed. Correct. The qualified range for fillet weld deposit thickness is incorrect. Well, you look at the weld deposit thickness for each welding process, GTAW, groove 1 inch, groove unlimited on the other side. Well, you can actually say, yeah, the thickness is incorrect. But it also depends on what you're qualifying for. But, I just had an itch. But if you could look at ASTM 312 grade. Let's see, ASTM. You look at the ASTM 312 grade, there's no thickness there. But each one, 3 to the 4 is 75 tensile. So, but there's no test, so we can't exactly go by that. The base metal number range, qualified range, is incorrect. Well, I really can't exactly say that one either, because there was no range for thickness. But what we can do is look at the answer explanation. Is 6.2.5, changing the polarity and GTAW would require requalification. And if we go into 6.25, too far. And I'm sure a lot of you can appreciate that I still have my book right in front of me trying to go through all this. There's a lot of information I'm not going to remember at all. Okay, so you look at performance qualification, as that's what this is. Performance qualification is always clause and or chapter, depending upon who you go through and stuff. Everybody's going to do something a little different. Clause 6. The whole deal of clause 6 is always performance qualification. So we go to 6.2.5. For gas tungsten arc welding, a change from alternating to direct current or vice versa, or a change in polarity. Now, so we have that, but at the very beginning, right underneath the 6.2, a change in any variable listed below from what was used in a welder's qualification test will require requalification of that welder. So, the qualified welding polarity is incorrect, as well as the answer and the explanation. The other half of that was the other answers are inaccurate, as RT can be used instead of bend tests. Table 11, the change in base metal number is allowed per table 13, and the fillet weld thickness is acceptable under table 10. But all those does not say, yes, you're the one that screwed up. But once you throw in the polarity, that is going to be a complete welding recert. So if you go, oh, the base metal is the wrong one, well, fine, let's get the right one. The qualified range, okay, well, what is the range I need to get to? Take whatever that is, cut it in half, do your weld test. No destructive tests were performed, which is true. It says side bend test. Well, it's 1 inch, I think it was. What was the thickness again? Thickness, I should have it in here. For G, a half inch equal to the 1 inch. So you can do the face and root bends as it's under the 3/4 spotlight. So no destructive tests were done. Well, they technically were done, just not the right way, because bending a piece of metal is destructive. But it's not like a V Sharpie test, which it just hits it and breaks it in two or anything. But yes, the wrong tests were performed. So the answer is B. The qualified welding polarity is incorrect. Let's go ahead and hit 24. Not literally, don't really hit it. Which of the following is true regarding performance qualification record WQTR number 2? So, whoops. Let's see, we're going number 2. So, document 11. Which of the following regarding our possibility of answers are a welder shouldn't be qualified to weld with GMAW, which actually that is right, because the welding process values as FCAW, but the range qualified is FCAW or GMAW. So you're right. You only are certified on what you qualify on in your test. If any of the variables change, you have to recertify unless those variable changes are qualified in what you are welding on. Now, if you're going on plate and you switch over to pipe, well, it's a whole new deal. If you weld on 1/2 inch and you need to qualify for a 3-inch, well, that's not going to qualify you. So, it's just amazing how many different times you have to retest just to do something. Heck, I certified 3-4 times in college alone. That was TIG, stick, MIG, all different things, including a consistency test, which we called it the brick. Take 2 pieces of angle iron, 3 1/4 inch, 3/8, something like that, and you make tabs off the length because that's 12 or 14 inches long. It wasn't. You had to use 2 sticks to get all the way up it. You do 1 horizontal, 1 vertical, 1 downhill. Let's see, what's that? Vertical, horizontal, oh shoot, it's been 25 years, so I don't exactly remember. Let's see. The welder shouldn't be qualified to weld on pipe. Let's go ahead and take a look. Yep. You look under the welding process, the variables. The X is on plate. So no, he cannot weld on pipe. The backing qualification range is correct. Let's see. Backers. Backing does not say whether it should be, but it, under the actual values, it has 1/2 inch thick M1 steel and M1 steel backing on the other. Let's see, ASTM A36. Oh, yep, it's all under 1. So yeah, you could technically, but the only way it's going to be allowed is if the blueprint says that it needs to have a backing plate or you qualify with a backing plate. In my opinion, don't ever qualify with a backing plate. It means that your test is going to not be as hard. If you put a backing plate inside of a piece of pipe, so you have that ring all the way around it, it becomes a more of a hinder than anything, because now you have extra friction with whatever's going through it, especially if it's liquid like oil, gas, and stuff. Now you got that friction in there and also a slight restriction. So your best bet is never to have a backing ring in a pipe. But when you're using plate, I could see that, especially if you're doing a really big thick piece and it's not going to be seen. It just means that you can weld that root in even hotter. So you know you get really good penetration. So let's say you're using a 6010 instead of doing like maybe, your standard might be like, say, 50 amps. I'm just shooting from the hip because I don't remember exactly how many amps for a 6010 is. But you shoot for the hip for like 50 amps. That's like, say, that's the low end. And you do okay with it. That's just like, that's your comfy spot. But that's if you have a gap. No backer. Now, you could jump it up to 60 with that backing and get it hotter and better fusion. So, but if they say backing strip must be removed, well, that backing strip might as well be like a copper or brass. I do not recommend lead. It's too soft, and it will actually make it weaker because lead will intermix with it. but it will not stick to it. As I do work in a lead factory, and I was amazed to find out that steel floats on lead. So it says the backing qualification is incorrect, which is true, because it just says M1 a half-inch thick M1 steel. The other one says M1 steel backing. Well, when you say M1 steel backing, that could be any number of thicknesses. So it's not. It's just not accepted under the range. And then we have a welder should be qualified for horizontal fillet welds. Well, that's true because it's 3G, 4G. And it said, and you go across, because you go across the C below, you look down, it says uphill. Okay, you're right. He's not. So the answer is only going to be none of the above. Now the explanation underneath it is none of the answers in A through D are correct. GMAW is allowed per 6.2.1 of the BOS. Welding on pipe is allowed per table 15. The backing range is not considered unacceptable in the BOS, and horizontal fillet welds are allowed per table 15. So if you're going to do anything, you kind of have to, well, rewrite it. No. But none of these are true regarding performance qualification. You want performance qualification, to me it's like how well you did. Let's cut that weld up. Let's bend it. Let's look at it. It's not like where you go into a store as a worker and your performance is based on, let's say a cashier. A prime example is a cashier. How many items can you scan in an hour when the store is really busy, and how many times did it register to beep and it didn't beep? So if it didn't beep, that will normally go against you, even though the eye saw it but didn't take it. So yeah, so you kind of get an idea like, oh well, my performance is going to be based on how well I did. It's not going to be, if it's pipe or plate or like that. It's when that thing cools, it's ground down, and it's bent. There's my performance qualification. It's when that final piece, whether it's bent, stretched, Sharpie, or anything that has to deal with looking at it, even through a visual looking at it. So the answer is D. E. None of the above. Let's see where I'm at here. Okay. For question 25, is WQTR1 documented correctly in accordance with the BOS? So let's go to number 1. So the 5 answers we have is yes, no, the insert gas backing qualified range is incorrect, no, the qualified range for the welding type is incorrect, no, the base metal M number qualification is incorrect, and no, insufficient bend tests were performed. So as I'm reading the explanation, it just says there's a lot of issues with this. But let's go ahead and take a look at it here. Document correctly in accordance? No, it's not. So we know it's not yes. It says no, the insert gas backing qualified range is correct. Well, let's see. It just says back weld or back weld with backing. That's not really. Yeah. I'm just like, it's how it's phrased. So no. The insert gas backing qualified range is incorrect. No, the qualified range for the welding type is incorrect. M number and M number is 1 to 1 to 1 to 11 to 1 through 11. No, that's quite possibly not it. And we're going to go through. It goes position, 4G to C below and uphill. Inert gas backing, none, and the actual value says none, but then it says range qualified with or without. If it says none, that's going to stay without. If you're going to weld with a inert gas backing, then it needs to have it. So we know that one's incorrect. No, the base metal M number qualification is incorrect. Well, yes and no. Technically, no. But when you're trying to do everything, you like to have a little bit more clarity about everything that they can do. And then no insufficient bend tests were performed. Correct, they were just side bends. Not front or not face or root, just side bends. So the answer here is no. The qualified range for the welding type is incorrect. Because here you're going like welding current, DCP, transfer, short circuit. Yeah, it's when you get into inert gas backing. None, then with or without. If we get into the qualified range, I don't quite see that on this, but I would say it's probably the 1/2 inch to 1 inch, but also that M number range is a little out of whack too. 1 to 1, then 1 to 11 to 1 to 11. That one actually should say 1 to 11 to 1 to 11. So, but the answer explanation says there are several issues with this piece, but the only one listed in the option is C. GM&W is a semi-automatic welding process, not a manual process. So yes, how they did the question and how they have it on the book is different wording, because under this is welding variables, this is type, and here this one is saying qualified range. So you can see where it really can be different. So this is where you know if it's wire feed, you know it's going to be semi-automatic. Saw, semi-automatic. Stick is technically stick is the only one that can be manual, because you can set up robots to TIG, wire feed, stuff like that, but not stick weld or small. It says here, therefore semi-automatic should be first listed for both the actual values and the range qualified. The addition of inert gas backing is acceptable per 6.2.9, although removing gas would not be acceptable. The M range is correct per table 13, and the correct numbers of bend tests were performed as this thickness was 1/2 inch. So I think it's on the eye of the beholder of the bend tests on that thickness range, because I have a deal that says 3/8 to 3/4 it needs to be a face root. Anything over 3/4 needs to be a side bend, and here we're doing 1/2 inch, and then doing side bends. So I guess it's just gonna be on the eye of the beholder of what they want to do. So the answer is C. Number 26. Now, does WQTR3 meet performance qualification requirements regarding the qualified ranges for pipe diameter and weld deposit thickness? Okay. Gas mill arc welding. Manual mill, back weld with or without. The possible 5 answers are yes, although the groove weld deposit thickness could technically be unlimited. Yes, each variable range is listed correctly. No, although the deposit thickness is correct, the diameter is incorrect. Although the diameter is correct, the groove weld deposit thickness should be limited. No, the fillet weld deposit thickness must be limited. So we're welding on plate. The actual value is for thickness is 1/2 inch to qualify for 1 inch. And the answer explanation is both the groove weld and the fillet weld metal deposit thickness are correct per table 9. Now the book of specs. The pipe diameter range is incorrect as the minimum. Oh, I just did a D&TD myself. I was on the wrong one. That was my bad. I totally take blame for that one. The pipe diameter range is incorrect as the minimum outside diameter must be 2 7/8 inches per table 9. Now if we go to table 9, oops, too hard. By a chunk. 7, 8. Sorry, my neighbors are out here banging around. Not sure what they're building. Table 9, here we go. Okay. For this to be done, small 2 5/8 of an inch groove to 1 1/4 inch. All right, so we have that. All right, this is both the groove weld and fillet weld metal deposit thickness are correct per table 9, which is fine because it says fillet welds all. It's all qualified. But the pipe diameter range is incorrect as the minimum outside diameter must be 2 7/8 inch. So, the deposit thickness was good. I mean, it had the right crown and everything. But it's the diameter is what gets it. Because if you're going to do that whole groove, you want to have the right size pipe. And in this case, the pipe is undersized. Number 27. Now, 27 is actually a visual. It says, which NDT method is shown here in illustration number 3? Well, it has a person with one hand on a little piece and then another one up on the monitor. Now, what he's doing is he has some gel down and he's going back and forth, looking for, it could be a laminar, it could be a crack, it could be slag, it could be a number of things. But it is actually ultrasonic testing. So it's just throwing a beam down. The options they give you is RT, which is radiographic testing, MT, which is metal or metallic testing, magnetic, PT, which is that penetrant test, and then ET, which is what's that called? Electro testing. I cannot remember the exact name of it. I've never had to use half of these. Now, I've done the penetrant test. I had a quick little deal with the UT, but that was about it. As shown in Module 9 of the Part B course, this photo shows a transducer and a screen for ultrasonic testing. 28, visual. You have 2 bottles, 2 cans of spray, one's red, one's blue. And this would be what we call a penetrant test. If you guys have never done a penetrant test, it's great. So if you're doing like a block, you cut it in 2, and then you grind it, sand it, make it look nice and stuff. You put the spray on it, which is red. Generally, it's red. I mean, they do have fluorescent too now. But you spray that on there. Let it sit for anywhere from 2 to 10 minutes, depending upon the manufacturer's wanting to do. You wipe it off, clean it real good, and then you put this white, clear spray on it. It doesn't take much. And any imperfection you have brings it right out. The bigger the imperfection, the bolder and redder it is. Well, a lot of us could figure out exactly what our problem was in those, that we didn't have to worry about, oh geez, what's it gonna be? Now, we already had a pretty good idea if we had a hole, or for lack of penetrating, or a slag in there. So, and we were all training, we were all in school. Number 29 is another picture. Yeah, have the 5 options, but this one here is actually MT. It's like a little horseshoe with 2 magnetic ends on it. So what it does is shooting if I remember, it's shooting waves back and forth, and if there's an inclusion or something like that, it pings through a system. So yeah. Okay, here we go. Now we gotta have some fun. Go away, book. You are on the floor. I'm going to come back to my camera, away from that. Now, last video I said I was going to do was show you my pieces. So, here we go. I ended up buying this, especially when it goes into pipes. So, they're on. No. You can always see the imperfections. You see right over my pinky here, that the light, so that way you can see any imperfections, especially if this end would be closed, one end would be closed. You can still see. This was an upgrade for me from a standard mirror. Don't get me wrong, I like the mirror. It's so nice, it's just nice to have the light. A V-Wack bit gauge. This will come up and I will show you how to use that a little bit. Have a little ruler here, 32nd, 64, and hundredths and tenths. I cannot find my other high-low gauge that I actually came with my kit originally. It's around here. I know I did throw it away. I just don't know where it is. Okay. This is... well, you could use it for pipe, mostly, but it's mostly... okay. Let me rephrase that. You can use it for plate. It's mostly for pipe. Now, something like this is designed to go... see here? Look at that. Go in, out, and when you loosen it up, it'll give you the height difference, tighten it down, bring it back out, and then you'll be able to read right on the back there. You see, you get some notches there, and as well as on this side here, and you're able to read. So this one is 32nd, this one's in millimeter, and always remember that a high-low gauge always starts on a 32nd. This is the caliper that came with my kit. Pretty nice. If you guys have never used one, definitely tinker around with it throughout the house. It is kind of fun just to see how thick some things are when you're trying to guess it off of a thousandths. And what I did to replace that one was... so I have to get it out. I did not want to spend the money I did on this one, but I did anyway, just because it was the only one they had. But it is a Husky, so you know it's Home Depot caliper. This was $33. But remember I told you you're going into millimeters and centimeters and stuff like that? But you turn it on, you have modes of and inches, fractions, millimeters, and inches and fractions, millimeters. So you have inches, inches and fractions, and millimeters. Oh, but when you go through your average assessment of general knowledge, if I remember right, you gotta know the difference between millimeters, centimeters, inches, and fractions, and they have the whole math code in there. So yeah, lots of fun. Standard protractor. I did not upgrade that. I was like, how are you really gonna upgrade that unless you go with digital? And these are your fillet weld gauges. I have used these many times in the past. They come in really handy, especially when you're doing corner joints. A magnifying glass. No, for some of us who are kind of blind. And a flashlight. One little toy I bought for myself. This was a little spendy. This is not allowed on the test, just so you know. Yeah, it's a little depth gauge. I had to order this off of Amazon. But if you turn it on, okay, you can just zero it in. No, not yet. Oh, 0. Then you can actually hit. Then I'll give it to you in millimeters. So, kind of neat. And just one moment, let me text my wife. I am going to have to continue this on a different video. I am very sorry. I have to go pick up my kids. I lost track of time. But anyway, like I said, when I get back, we're going to go through all this. We're going to do all the pipe. We're going to do the plate. We're going to do roughness. And we're going to have a little bit of fun with my tools. So anyway, you guys take it easy. Catch you on the flip side, and I will talk to you later.